Welcome to my channel Mugambe Brand 256. So today we are going to look at how we can determine the specific heat capacity of a solid by the method of mixtures. And then we shall need the following materials with us. So we shall need a copper calorimeter, a stirrer, a thermometer, water, a source of heat, and then the thread. So we shall see what these materials that we need, the purpose that they will serve. Well, so this is a simple diagram that I came up with. We shall have a thermometer here. The thermometer will be taking the temperature readings inside here. We shall have a solid also whose specific heat capacity we are interested in. So we shall also have a stirrer which is going to help us ensure the uniform distribution of heat in the mixture here. So we shall also need to rag this copper calorimeter in order to reduce on the heat losses to the surrounding. So with us here inside is the copper calorimeter at that point. So what are the procedures that we are going to go through while determining the specific heat capacity of this solid here? First of all, we shall measure and record the mass of an empty calorimeter of non-specific heat capacity, Cc, and then the mass of the calorimeter, we are recording it as Mc, an empty calorimeter. Then step 2, we shall pour some water of known mass Mw in the calorimeter until it's about to get full. Then the next thing, after us measuring the mass of the calorimeter and then also pouring a known mass of water in the calorimeter, so we shall use a thermometer to read and record the initial temperature of the calorimeter and water, and we shall record it as θ1. Then the next step would be, so we shall have to heat the solid of known mass Ms whose specific heat capacity Cs we are interested in until it attains a temperature θ2 in boiling water. Then the next step, we shall quickly transfer the solid into a calorimeter that is containing water. Then we shall cover the calorimeter and stir the mixture continuously. This is done to ensure the uniform distribution of heat until when we reach steady values of temperature. So the next step would be reading and recording the final temperature of the mixture. Remember here at first, when we poured water in the calorimeter, so we had to record the initial temperature of water and the calorimeter, which was θ1. So if you had to slope a little bit down here, then remember we also had to heat this solid here and it attained a higher temperature, which temperature is θ2 in this particular case. So after quickly transferring the solid into the calorimeter that is containing water, then stirring, thereafter we shall read and record the final steady temperature of the mixture, which is going to be θ3. So in this particular case, there are two things that we have to look at: the body that does lose heat and then the bodies that do gain heat. So that will be our guiding principle in the determination of specific heat capacity. So the next step would be for us to calculate the heat lost by the solid. Remember, the water and the calorimeter are relatively low temperatures compared to the solid that has been heated, and therefore the solid will lose part of its heat to the water and the calorimeter, and therefore the heat that is going to be lost by the solid will basically be the mass of the solid times the specific heat capacity Cs times the temperature difference d theta. Then we continue. But anyway, the temperature difference here for the solid is going to be the temperature that it came with, which was θ2 minus the final temperature of the mixture, θ3. Then the next step is for us to calculate the heat that is gained by the water. So the heat gained by the water. So that will basically we shall have this formula. It will basically be the mass of water times the specific heat capacity of water times the temperature difference. So the temperature difference would basically be the final temperature of the mixture, theta 3 here, then minus the initial temperature of water and the calorimeter, which was theta 1. The next step is for us to calculate the heat that has been gained by the calorimeter. Remember, in this particular experiment, we basically look at the heat that has been gained by the calorimeter and the water. So we do neglect the heat that has been absorbed by the thermometer and the stirrer. So those are some of the assumptions that we take. So we do neglect the heat that has been absorbed by the thermometer and the stirrer. So the heat that has been gained by the calorimeter would be the mass of the calorimeter times its specific heat capacity times the temperature difference, which is going to be the final temperature of the mixture, which is theta 3, minus the initial temperature of water and the calorimeter, which was theta 1. The next step is for us to determine the specific heat capacity from the heat that is lost by the solid is going to equal to the heat that is gained by water plus the heat that is gained by the calorimeter. Remember, energy can neither be created nor lost, but it is transferred from one form into the other. So as this body is losing energy, which is the solid or specific heat capacity we are interested in, the water and the calorimeter are gaining this energy that is being lost by the solid. And therefore, assuming that you have no heat losses to the surrounding, the heat that is lost by the solid is equal to the heat that is gained by water and heat gained by the calorimeter. So we added this expression for the heat lost by the solid. We had it, then we also add the expression of heat gained by water plus that expression of heat gained by the calorimeter. But what we are interested in is this CS, which is the specific heat capacity of the solid. Then our next step would be for us to substitute for these temperature differences here. So for the temperature difference of the solid, remember it came with temperature theta 2, which was higher than theta 1. So it is going to be theta 2 minus the final temperature of the mixture theta 3. Then for the case of water, remember water was at relatively low temperatures. So it is going to be the final temperature of water of the mixture minus the initial temperature of water. Then for the case of the calorimeter, it is going to be the final temperature of the calorimeter minus the initial temperature of the calorimeter, which was theta 1. And our task here is to make the CS, or the specific heat capacity of the solid, the subject. And when we make it the subject, we come up with this expression here. And therefore, we are able to determine the specific heat capacity of the solid. Thank you so much for watching. We meet in the next tutorial.